All right, Unit 2 test review. So describe how to graph a parabola. So we know parabola is a U shape. So I would say find vertex, x and y, intercepts, more points if need be. Something like that would be good enough. What is the fundamental theorem of algebra? Well, it's saying that the highest power of any polynomial, doesn't have to be a quadratic, any polynomial this is true, the highest power in all the terms will be the number of x-intercepts it has, or number of solutions, really, more accurately, because they could be imaginary solutions, which means they wouldn't cross the x-axis. So you would say 2 solutions, highest power, and you could even just point to find the zero product property. So the zero product property says if you have a polynomial that's in factored form, quadratic we're dealing with in this unit, but it's all polynomials. If it's factored like this and set equal to 0, as long as it's set equal to 0, we can set each individual factor equal to 0, and we can just solve. So you'd add 2, subtract 3. So it just says if it's equal to 0, you can just split it apart. Write down intercept form and how to find the vertex. Intercept form. Intercept form is this like factored form. It's another way of saying factored form. So it says write the and describe how to find the vertex. So then I would say find x-intercepts. Vertex is halfway. The x value is halfway of the vertex. Then once you know, oh, it's, at this point. So let's say our x-intercept is at, for easy purposes, I'm going to do 2. And let's say an x-intercept is at 4. The vertex, the axis of symmetry is at 3, since it's halfway. Then you'll go plug in x equals 3 back into the function, for example, to find the y value. Write down the vertex form, describe how to find the vertex. Vertex form is a x minus h squared plus k, and that's just the general form. So I could have written the general form as this kind of plus, it doesn't matter what variables I use, but anyways, right here is vertex form, and then find the vertex. Well, vertex form is shifted form. So we just state the shift. For example, 2x minus 3 squared plus 7. Right 3 up 7 would be at 3 comma 7. So right 3 up 7 would put our vertex at 3, 7. That is shifted form. It's also known as vertex form because the vertex is very easy to find. What is the growth rate of a quadratic? It's our a value, and it's usually 1, 3, 5, 7. So then we have to just times our a value, whatever here in front, whatever number that is, we times by the regular acceleration of a quadratic, which is 1, 3, 5, 7. So I would just show a quadratic that doesn't cross the x-axis, has imaginary solutions. How do you find the y-intercept of an equation? Plug in x equals 0, of course. So right here you'd plug in 0. That'd be 0 squared plus 0 minus 3, which would be obviously negative 3. So 0, negative 3. What do x-intercepts of a graph represent? Solutions. I don't know what they're going for there. Where it touches the x-axis. You know what I mean? Okay, so let's go ahead and do this. It says identify the x-intercepts. Since they're at whole numbers, these are really easy. This one's an easy one. We write them as x, y points. And negative 2 comma 0. The y-intercept is not seen, but we could actually find it. We'd have to write the equation. So it depends how advanced we're talking here. Let's just do it the most advanced way, I guess. So what's the equation of this? Well, let's write it in factored form. So we know it's ax plus 6 and x plus 2. Remember, these will be opposite signs of what we see on the solutions because we would work backwards, you know, we would go, so x equals -6. So if we work backwards, that'll be x plus 6. Anyways, so this is what we're dealing with. This is the form of our quadratic. Y equals a times x plus 6 times x plus 2. We need to know acceleration. So let's start here at the vertex. Over 1 up 1, over 1 up 3. So our acceleration is just 1. So our y-intercept is, we can go plug in 0. Plug in x equals 0. So that'd be 0 plus 6 times 0 plus 2, which equals 6 times 2, which is 12. Plug in 0, you get out 12. Or you could just keep the 1, 3, 5, 7 pattern going. 1, 3, and then this one would be 5, 7. So you'd have to count and figure that out. I almost think this is easier just to write out the equation. Our axis of symmetry would obviously be located halfway between these x-intercepts. So our axis of symmetry is at x equals -4. Our vertex is -4, negative, so -4, -1, 2, 3, 4. Is it a max or min? Since it's a smiley face, it's a minimum. Domain for all quadratics is left and right. Well, for anything, it's left and right, but a domain for all quadratics grow left and right forever. So it goes from -infinity to infinity. Our range is from -4, furthest down to furthest up. So that'd be -4 to infinity with a bracket. So again, they're making our life pretty easy here. Looks like our x-intercepts are at whole numbers again. So -2, 0, and +6, 0. The y-intercept you can even see really easy, over 0 up 6. So we didn't have to do as much work on that one. The axis of symmetry goes through the vertex here. So let's just even write our vertex first. Our vertex is 2 up 8. 2 up 8. So it's at x equals 2. It is a frowny face, so that's a max. The vertex is a maximum. The domain of all quadratics is -infinity to infinity. The range is -infinity up to the highest value of 8. 8 gets a bracket. Remember, infinity doesn't ever get a bracket. Oh, I skipped like a whole bunch of stuff there. I didn't see it. Increasing and decreasing. So let me erase some of this stuff. So right here, our vertex will be helpful because that splits apart where it's increasing to decreasing. So it's increasing right here, but a common error again is people will answer from -4 to infinity, but that's wrong. We don't answer it like that. Well, they're looking here. They go from -4 to infinity. That's not how we answer. Our eyeballs look at that, but we answer from left to right. So it's actually this -4 to infinity that it's increasing. So -4 to infinity. Usually with increasing and decreasing, you don't use brackets. Then aren't we decreasing here? So you would say I'm decreasing from -infinity because we answer from left to right. Yes, our eyeballs look up and down, but we answer from left to right from intervals of x. So we're decreasing from -infinity to -4. It's concave up, opening upward. Positive means where is it above? You have to remember all these vocabulary words because a lot of kids get them confused. Positive means where is it above the x-axis. So right here is where it's positive and right here's where it's positive. Again, though, you answer from left to right. You're looking with your eyeballs down to up, but you're answering from left to right. So we are positive from -infinity to -6. We're also positive from -2 to infinity, which means we're negative below the x-axis right here from -6 to -2. And then end behavior is up and up. If they make us write end behavior a little more fancy, then we would say, okay, so we know it's up and up. Here's our visual aid. We would say as x goes to infinity, that would be that way. Our y values also go to a positive infinity. And as x goes to -infinity like this, our y values go to positive infinity. That's just a fancier way of saying up and up. See, it's to the far left and far right. It's up and up. Okay, so looking at this one, decreasing. Where are we decreasing? Decreasing would be right here. So you'd say from 2 to infinity. We're increasing from here to here. So we're increasing from negative infinity to 2. Very common for kids to answer, like I said, like they'll go, oh, from negative infinity up to 8. And they're on the right track, but it's just not how we answer increasing and decreasing. Positive is where you're above the x-axis. So aren't we above the x-axis right here? So that'd be from negative 2 to 6. Which means we're negative below the x-axis. So that'd be negative infinity to negative 2. Then union. I haven't been using unions very good here. Then union from 6 to infinity. We're answering from left to right. Direction of opening, concave down. Or just downwards. And our end behavior is down and down. Since it flips upside down like this, if we're going to answer it the fancy way, again, we would go, okay, as x goes to infinity, that's like saying as x goes to the right, our y's go down to negative infinity. Then as x goes to negative infinity, our y's go down to negative infinity. That's saying down and down, a little more fancy. All right, this is the different form of a quadratic. So right here, if we're going to graph this, we're going to first state the shifts. Right 3, up 4. So right 1, 2, 3, up 1, 2, 3, 4. We can do the rest of this many different ways. From here, since this is our vertex, it's also our axis of symmetry here. Now, if you want to find x-intercepts, you can. If you want to do the 1, 3, 5, 7 rule, you can. I generally, it just depends on the problem. So 1, 3, 5, 7 needs to be times by our a value, which is negative 3. So it's actually negative 3, negative 9, negative 15, negative 21. So we're going to go over 1, down 1, 2, 3. Over 1, down 1, 2, 3. Then we're going over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. We have enough points to finish graphing that, but now we'll answer the questions. What are the x-intercepts? Oh dear. If it's asking that, we can't just say, oh, well, they're decimals. We got to actually find them. X-intercepts are when y equals 0. So we'll say 0 equals negative 3 times x minus 3 squared plus 4. We'll then just solve for x. So first we'll subtract 4. Negative 4 equals negative 3 times x minus 3 squared. We'll divide by negative 3. So 4/3 equals x minus 3 squared. We'll square root it. I have to show my work over here. So we have the square root of 4 over the square root of 3 equals root and power cancel out x minus 3, which is 2 over root 3. Square root of 4 is 2, of course. So I wrote 2 over root 3 equals x minus 3. Then the question is, are they going to force you to rationalize the denominator? I guess it never hurts. So we'll multiply by root 3 over root 3. Since I guess we really shouldn't have a radical on bottom. So that's 2 roots of 3 over square root of 9, which is just 2 square roots of 3 over 3 equals x minus 3. We're then going to add 3. So we have 3 plus, oh, and I also should have said this, and I didn't, and bless my soul, it's very important. When solving by taking square roots, you need a plus and minus in front. So we actually have plus and minus 2 square roots of 3 over 3, like that. So our x-intercepts are 3 plus 2 roots of 3 over 3, comma 0. And also 3 minus 2 roots of 3 over 3, comma 0. Now, if you're going to do it on your calculator, you would find the decimals. So you would just type this into your calculator, hit second trace, find the x-intercepts. They would only give you decimals. It just kind of depends on, your teacher or the year or whatever we decide to do. But the decimal would match this number and this number. So if you were like, oh, I wonder if my decimal's correct, you could then type into your calculator 2 plus 2 roots of 3 divided by 3. And then hit enter and then compare it to your decimal. I don't know. kind of every year we've done something different. Like, oh, no, we want you to do it by hand. And then some years we're like, nah, you can just use your calculator. It is good practice to do it by hand. Either way. The y-intercept is when x equals 0. So if we go plug in 0, that would be -3, 0 minus 3 squared plus 4, which is -3 times -3 squared plus 4, which is -3 times 9 plus 4. So -3 times 9 plus 4 is -23. So the y-intercept is 0, -23. Axis of symmetry is easy on this one because we can see our vertex here. So our axis of symmetry is at x equals 3. Our vertex is 3 up 4. It opens down. It's concave down. So it's a max. Downward, concave down. Domain is -infinity to infinity. Our range is -infinity up to 4. Right? -infinity up to 4 is the range. Increasing, again, is when are you walking uphill? You need the vertex for this. So we're increasing right there. So you'll say from -infinity to the x value of 3, we're increasing. We're then decreasing from here to here. So we're decreasing from 3 to positive infinity. You have to keep in mind what increasing and decreasing versus positive and negative is. Positive is like when are you up on top of the x-axis. So it would be from this x-intercept to this x-intercept. You actually need x-intercepts for that one. So we're positive from 3 minus 2 roots of 3 over 3 to the next x-intercept was 3 plus 2 roots of 3 over 3. Then negative will be all highlighted. There's just a lot going on right there and right there from that x-intercept. I mean, from, you know what I mean, this piece up to the x-intercept, and then from this piece up to the x-intercept. So we're negative from -infinity to 2 or 3, sorry, let me erase this. 3 minus 2 roots of 3 over 3 united with, and then we're also negative from 3 plus 2 roots of 3 divided by 3 to infinity. So it's just not very pretty numbers, but it's not that it's necessarily hard. It's just not pretty and so straightforward as when we have whole numbers. Our end behavior is down and down. X-intercepts we already found. Oh, okay. I was like, what? But it's the start of the new problem. Wow, that one was a decently advanced one only because it didn't have the prettiest of numbers. Let's see if this one goes a little better. So the shift is left 4, down 3. So start at 0, 0, left 1, 2, 3, 4, down 1, 2, 3. Let me check to make sure this is an emergency. Where's my phone? All right, here. Okay. Now from here, we know it smiles because it's a positive number in front, and we can do the 1, 3, 5, 7 rule, and our a value is 1. So when we just times that by 1, we're going over 1 up 1, over 1 up 1, over 1 up 1, 2, 3, over 1 up 1, 2, 3. That's enough to graph it. X-intercepts then, again, though, look kind of like at decimals. So let's just see what we can do here. X-intercepts are when y equals 0. So we say 0 equals x plus 4 squared minus 3. From here, we add 3. So we have 3 equals x minus 4 squared. We then square root both sides. Put a plus and minus. So we have plus and minus the square root of 3 equals x minus 4. Remember, square root of 3 is just a decimal. So we'll add 4. So there it is. Our x-intercepts are 4 plus root 3 comma 0 and 4 minus root 3 comma 0. Which are just decimals, keep in mind. It's just, this is like the pretty way of writing the decimal. Y-intercept are when x equals 0. So if I go plug in 0, that would be 0 plus 4 squared minus 3. So that'd be 4 squared minus 3, which is 16 minus 3, which is 13. So plug in 0, get out 13. The axis of symmetry is at x equals -4. Our vertex is at -4, -3. It's a minimum. Opens upward. Hopefully you guys are keeping up here. Sorry. Domain is negative infinity to infinity. That's true for all. That's true for all quadratics. Okay, then our range is from -3 to infinity. We're increasing means we're walking uphill from -4 to infinity. And we're decreasing from, I'm telling you, even though I'm telling you to answer left and right, there's going to still be a huge portion of kids that they answer up and down instead of from left and right. We're decreasing from negative infinity to -4. Positive, again, is a little harder because you have to go off of x-intercepts. They're just not the pretty values. Remember, this one would be 4 minus root 3, and this one would be 4 plus root 3. So we're positive above the x-axis. So like this right here and this right here are positive. So you would say from negative infinity to 4 minus root 3 union, you're also positive from 4 plus root 3 to infinity, which means we're negative from here to here. So we're negative from 4 minus root 3 to 4 plus root 3. Then our end behavior is up and up. And it looks like that's it for that one. Okay, again here. Holy shnikes, shnikes, shnikes. This is long. Okay. So again, this just shifted left 4 down 3. Left 1, 2, 3, 4 down 1, 2, 3. Remember, for shifts left and right, we do opposite. Shifts up and down, we do not. We know it's going to frown upside down because our leading term or our leading coefficient is negative. So we could do the 1, 3, 5, 7 rule. I'm do it down here. 1, 3, 5, 7 times -2, which is -2, -6, -10, -14. So I'm going over 1 down 2, over 1 down 2, over 1 down 1, 2, 3, 4, 5, 6, over 1 down 1, 2, 3, 4, 5, 6. X-intercepts are none. Doesn't cross. There are still 2 solutions, so it's all in the wording. If they want x-intercepts, you just get to say none. If they want solutions, they're still solutions. They're just imaginary. All right, so here we go. Let's see here. So y-intercept is when we plug in 0. So if I go plug in 0, that would look like this. -2 times 0 plus 4 squared minus 3, which will be -2 times 4 squared minus 3, which is -2 times 16 minus 3. -2 times 16 minus 3 is -35. So you'd say I plugged in 0, got -35. The axis of symmetry is at x equals -4. Remember, right here is our axis of symmetry. Our vertex is -4, -3. It's a maximum opening downward. Domain is from -infinity to infinity. Our range is from -infinity up to -3. Bracket on range. Increasing is from -infinity to -4. We're decreasing from -4 to infinity. It's like, where are you walking uphill? Where are you walking downhill? Positive means above the x-axis, so never. None. Negative is always. It's always below the x-axis. Our end behavior is down and down. And now we'll just graph. This should be way quicker because the graphing part is the easy part. Okay, so right 2, down 1. So you go right 2, down 1. Then do the 1, 3, 5, 7 times 1/2. So that'd be 0.5, 1.5, 2.5. So you're going over 1, then you're going down 1/2. Then from there, you're going over 1. Oh, over 1 would be like clear over here, huh? Then you're going down 1.5. That can be hard to visualize here. Down 1 would be that, and then 1/2 would be that. So that would be my parabola right there. I'm done. So graphing this one, we would say that it's shifted left 1 up 2. So from 0, 0, left 1 up 2. This is like an in-between type thing. I hate when the graphs aren't just normal graphs. 1, 3, 5, 7 times -4 be -4, -12, -20, -28. We're not going to go that many. So we're going over 1. That's only right there. Down 4. So that'd be down 2, 4, 2, 4. And we're going over 1, which would be right here-ish. Down 12. 2, 4, 6, 8, 12. Over 1, down 2, 4, 6, 8, 12. I hate when the grid's off because that can throw me off. I start going the wrong distances. It's just easy to do. Okay. Solve the equation. Solving is when we get it set equal to 0 if it's not already, which that's just generally what we do. If we have a function that's set equal to y or f of x, we set it equal to 0. In this case, it's already equal to a number. It's -5. So you can just solve for x. We just solve for x. That's what's nice about this like shifted form is you can just like get x alone. So you're going to first add 10, which -5 plus 10 is 5. We're then going to divide by -4. We're going to then take x plus 2 squared equals -5/4. We're going to square root both sides. So then we have x plus 2 equals plus and minus. Root and power cancel out. We have plus and minus when solving by taking square roots. You need a plus and minus. We have the square root of -5 over the square root of 4. Why did I put the negative with the top? Because I can choose where I want the negative. Do I want it on top? Do I want it on bottom? Where do I want it? I want it on top. I don't want an I in the bottom. Remember, we don't like i's in the bottom. So now from there, simplify your radicals. So that would be x plus 2 equals plus and minus I square roots of 5, right? That's the same thing as the square root of -1 times 5, so we pull out an I. And then on bottom, the square root of 4 is just simply 2. Now from here, get x alone, so we'll subtract 2. Order doesn't matter. It's more common to write -2 plus and minus I square roots of 5 over 2. So 2 imaginary solutions. All right, right here, solving for x, first subtract 6. It's nice with this type of quadratic. Not all quadratics can you just solve for x. A lot of them you have to do much more, but shifted form you can very easily. Divide by -2. So we're dealing with that. -2 divided by -2 is 1. We're square rooting both sides. So we have x plus 8 equals plus and minus the square root of 1. So many kids accidentally leave their answer as square root of 1. It's not square root of 1. What is the square root of 1? Square root of 1 is 1. So x plus 8 equals plus and minus 1. We're then going to minus 8. So we have x equals 1 minus 8 and -1 minus 8. So we have 2 solutions. You can actually put those together. Don't leave it like that. Look, what's 1 minus 8? -7. What's -1 minus 8? -9. So our 2 solutions are -7, -9. Again, because it's shifted format, we can just solve for x. So we'll first add 6. Divide by -8. So we have x squared equals, these both divide by 2. So that'd be 3, a -3/4. Why did I pull the negative from the bottom to the top? Because we like negatives on top better. You can do that. Think about why. If you have -3/4 and it's written on top, it's the same thing as 3 divided by -4. They're the same. So which one do you pick? This one, you like the negative on top or in front. Square root both sides. So we have x is equal to plus and minus the square root of -3 over the square root of 4, which we know is I roots of 3 over 2. So we have x is equal to plus and minus I square roots of 3 all over 2. I'm hoping at this point we're like quick enough at being able to go, oh yeah, that's just I roots of 3. And then the square root of 4 is 2 because it's a perfect square root. right, we're adding 7, dividing by, let's do 2 birds with 1 stone. Add 7, divide by 6. So that'd be x plus 5 squared equals add 7, divide by 6. Square root both sides, put a plus and minus. So x plus 5, and the plus and minus would cancel out on the left. So we have x plus 5 equals plus and minus square root of 7 over square root of 6. How picky is your teacher? The question is, it really just depends on the year, on what we, are strict on or not strict on. But we would simplify square root of 7 and square root of 6, which neither of those have groups of 2. So then, is that simplified enough? Well, I don't know. Is your teacher having you rationalize denominators or not? Usually, yes. So we would multiply by root 6 over root 6. So it'd be the square root of 42 over the square root of 36, which is x plus 5 equals plus and minus. The square root of 42 doesn't simplify, but the square root of 36 is 6. See how that got rid of our radical on bottom? Now from there, we'll minus 5. So we have x is equal to negative 5 plus and minus the square root of 42 all over 6. There's your solutions. Said solve. Yep. See, these are factored form. Solving factored form is like the easiest. We set each factor equal to 0. So each factor is set equal to 0. If you set 2 equal to 0, x plus 10 equal to 0, and x minus 6 equal to 0, we can split it apart because it's set equal to 0. The zero product property rule says as long as it's set equal to 0, if it's factored, that is, only if it's factored. Factored means in multiplication form, you can split it apart. Now, does 2 equal 0? No, it's a contradiction, so that is not a part of the solutions. We know that this number in front doesn't affect solutions. Why? Well, I just showed you why. Subtract 10. X equals negative 10. Add 6. X equals 6. Those are our 2 solutions. Solutions are x-intercepts. Cool. This one is set equal to 0 and it's factored. So we're going to set this and this equal to 0. We're then solving for x. So we'll add 2. Divide by 5. 2/5. Add 4. X equals 4. It's not weird to get fractions as a solution, as an x-intercept. Fractions are numbers like any other numbers. All right, let's set each of these equal to 0. So set negative x equal to 0, x minus a third equal to 0, and then solve for x. So we'll divide both sides by negative 1, which is 0. There's a solution. It's not weird to get 0 as an answer. 0 is a number like any other number. 0 and a third. Again, these are factored and set equal to 0, so we can just set it equal to 0 individually and solve. See, this wouldn't work if this was equal to 6. No, you literally have to multiply everything out. Like all this, you'd have to distribute, move the 6 over, then solve by a different method. So right here, we'll add 11, then divide by 2. We'll subtract 7, divide by 3. Since those are just solving linear equations, I am doing those pretty quick. Holy cow, this is taking forever. I might pause the video and upload the second video. Or should I just keep going? Okay, so let's graph these. So with this type, usually we first find the x-intercepts. So it's at positive 6 and positive 4. We then find the axis of symmetry, which will be located halfway between. So right here is our axis of symmetry located halfway between. So we know our axis of symmetry is at x equals 5. We just don't know where the y value is at the vertex till we go plug in 5. That's how functions work. If you're like, what's the y value? At that x right there at 5. What's the y value? You go plug in 5. That's how functions work, my friends. So that'd be 3 times negative 1 times 1, which would be negative 3. So 5, negative 3 is the vertex. 1, 2, 3. And it opens upward because this is positive. We could then do the 1, 3, 5, 7 rule if we wanted. So start at the vertex, but it's times by 3. So it would be 3, 9, 15, 21 rule. So over 1 up 3 is the purple points. Then from the purple points over 1 up 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 1, up 1, 4, 6, 7, 8, 9. Now we have enough to graph. Our x-intercepts are at 6, 0, and 4, 0. Our y-intercept, we got to go plug in 0. We can't see it, so we got to go plug it in. So that would be 3 times 0 minus 6 times 0 minus 4, which would be 3 times negative 6 times negative 4. Oops. There we go. Which is 72. 0 up 72. Our axis of symmetry is at x equals 5. Our vertex is 5, negative 3. It's a minimum. Upward. It's opening upward. Our domain is negative infinity to infinity. Our range is from negative 3 to infinity. Increasing is when you're walking uphill. This is increasing, so you use your vertex. We're increasing from, wait. Yeah, okay. We're good. We're increasing from the x value of 5 to infinity. We're decreasing right here. So we're decreasing from negative infinity to negative or to positive 5. Positive is when you're above the x-axis. So we're positive from negative infinity to 4, united with also from 6 to infinity. Negative is below, right down here, below the x-axis. So that was our x-intercepts we're using, as you can see. So we're going from 4 to 6. We're negative, and our end behavior is up and up. All right, hang in there, guys. We're all barely hanging on for dear life here. All right. So looks like our x-intercepts are at negative 2 and 4. Which means we have to go halfway between. So how many units total? 1, 2, 3, 4, 6. So 3 units. 1, 2, 3. Okay. Right here is my axis of symmetry at x equals, it looks like 1. Okay. So now from here, we know to find the y value of the vertex, we got to go plug in 1. So it'd be negative 1 plus 2, 1 minus 4. We do show kids how to do this on the calculator as well. So I am doing it all by hand, but you know, there are ways to do it on the calculator. It just kind of depends on your teacher, if you're allowed to do it by calculator or if you are asked to do it by hand. It's honestly good practice to do it by hand, but it just kind of depends on the year, what you're looking for out of the problem. So over 1 up 9 is the vertex. And then we're going to do the 1, 3, 5, 7 times negative 1. Since our a value is negative 1, so that'd be negative 1, negative 3, negative 5, negative 7. So over 1 down 1, over 1 down 1. And that's enough points to get graphed. X-intercepts are at negative 2, 0, and at 4, 0. The y-intercept is 0 up 8. As you can see, I didn't even have to go plug in 0. I could, though. Axis of symmetry is at x equals 1. Our vertex is at 1, 9. It's a max. The vertex is a max, opening downward, concave down, however you want to say it. Domain is negative infinity to infinity. Our range is negative infinity up to 9. Increasing is when we're walking uphill. So we're walking uphill from negative infinity up to the x value. Don't accidentally say 9. That's the y value. I always do it too. I have to remind myself, no. It's from left to right that we answer. So from negative infinity to 1. Then we're decreasing from 1 to infinity. Positive is above the x. Wow. Positive is above the x-axis here. So we're positive from negative 2 to 4. Then we're negative from here and here. So we're using x-intercepts here. So we're negative from negative infinity to negative 2. We're also negative from 4 to infinity. And our end behavior is down and down. Good stuff, guys. Can't believe I'm being forced to do this again. Bless your guys' souls for hanging in there. You know, that's just a lot of work here. Okay, So x-intercepts are at -5 and -3, which means our axis of symmetry is at -4, which means we have to go plug in -4. So that'd be 2 times -4 plus 5 times -4 plus 3, which would be 2 times 1 times -1, which would be -2. So -4, -2 is our vertex. Then 1, 3, 5, 7 times the 2, which would be 2, 6, 10. Over 1 up 2. Over 1 up 1, 2, 3, 4, 5, 6. 5, 6 on this side. Graph. Our x-intercepts have luckily been at like whole numbers, so that's helpful. -5, 0, and -3, 0. Our y-intercept, we're going to have to go plug in 0. We can't see it. So if we go plug in 0, that'd be, let's see. Plug in 0, that would be 2 times 0 plus 5 times 0 plus 3, which would be 2 times 5 times 3, which is 30. Axis of symmetry is at x equals -4. We already wrote in our vertex, it's a min. It's opening upward. Domain is -infinity to infinity. Our range is -2 to infinity. That. Yep. Increasing is walking uphill. So we're increasing from -4 to infinity. We're decreasing when we're walking downhill. So we're decreasing from -infinity to -4. Positive is above the x-axis there. So we're positive from -infinity to -5. We're also positive from -3 to infinity. We're negative from -5 to -3. Our end behavior is up and up. Holy cow. Now, luckily, for the most part, this should go pretty quick, only because now at least we don't have to answer all the questions about it. We can just like graph it. So our x-intercepts are at +7 and +3. To graph this, we need the vertex, so we go halfway between, which would be at 5. We'll go plug in 5. 1/2 times 5 minus 7 times 5 minus 3, which is 1/2 times -2 times 2, which is 1/2 times -4, which is -2. So 5, -2 is the vertex. Then 1, 3, 5, 7 times 1/2. Oh, it's times -1/2. That can't be right then. I messed something up because if my vertex is located right there, it would have to smile, and it can't smile, it has to frown. So what did I mess up here? 5 minus 7, positive. Should frown, and my vertex has got to be wrong. Huh. What am I missing here? 5 minus 7 is -2. Oh, right here. This was a -1/2. So it's actually +2. Oops. Right. There's where I should have had it. Okay. Hallelujah. We figured that out. Okay. So it's actually times -1/2. So that'd be -1/2, -1.5, -2.5. So I go over, from the vertex, I go over 1 down 1/2. Over 1 down 1/2. And you only need 5 points. So I'm like, good enough. I'm done with that problem. Okay, right here, I find my x-intercepts. I set each of these equal to 0. So -2x equals 0. X plus 4 equal to 0. And then we solve for x. So divide by -2. X equals 0 as an x-intercept. Subtract 4. X equals -4 is another x-intercept. So the vertex will be at -2. That means we need to go plug in -2. So it'd be -2 times -2, -2 plus 4. Because I know my vertex is located at x equals -2. Now we got to figure out the y value. So that'd be 4 times 2, which is 8. -2, 8 is my vertex. Then I do the 1, 3, 5, 7 times a. My a value is -2. So that would be -2, -6, -10 over 1 down 2. Then that's enough points. I didn't connect the pink dots on accident because I'm hurrying, but I think we get the picture. Okay. X-intercepts are at 3 and 5, which means my vertex is located halfway between at 4. So I go plug in 4. 3 times 4 minus 3. 4 minus 5, that'd be 3 times 1 times the -1, which is -3. So 4, -3. That is my vertex. 1, 3, 5, 7 times 3 is 3, 9, 15. Over 1 up 3, over 1 up 3, already taken care of that. Then we're going over 1 up 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 1 up 9. And we have enough points to connect the dots. And last but not least, -5 and -1. Our axis of symmetry is halfway between, so it's obviously here at -3. We go plug in -3. -3 plus 5 times -3 plus 1, which would be 2 times -2, which is -4. So it was -3, -4. And then it's 1, 3, 5, 7, because there's only an A value of 1. It's just 1, 3, 5, 7. So over 1 up 1, over 1 up 1. And we have enough points to connect. You need 5 points to get full points. And whoo, hallelujah, I think we're all glad that is over.